key for velocity and other rates of change. There's a lot of pages here, but pretty straightforward stuff. So I'm just going to blast through it. Volume as a function of side length. So side times side times side, it's a cube. They're all the same. Instantaneous rate of change with respect to a side S is dV ds 3s squared. What's the rate of change when s equals 1 and s equals 5? So that would just be 3 dV ds when s equals 5. That would be 75. No units here because they didn't give me any units, so I don't give any back. Don't assume meters, meters squared, anything like that. Oh, look, units. S is measured in inches and V is measured in cubic inches. dVds would be cubic inches per inch. And you would say, well, just cancel that, get inches squared. I would leave it like that because it's telling me it's a rate of volume changing per rate of linear inch. Just advice. Equilateral triangle. So, equilateral triangle, 60 degrees, S, 30 degrees, that's S root 3. No, it's not. That's S over 2. No, it's not. That's S over 2, obviously. And then that is S root 3 over 2. 30, 60, 90, or you can do Pythagorean theorem, whatever floats your boat. So, area of a triangle, based on its side S, it's 1/2 base, the whole base is side, times height, which is S root 3 over 2. In other words, S squared root 3 over 4. I like to put the root 3 in the back. You can put it in the front if you want, doesn't really matter. Find the instantaneous rate of change of the area with respect to a side. So 2S root 3 over 4. S root 3 over 2. Value at the rate of change, S equals 2, S equals 10. dA, ds, S equals 2 equals 2 over 2 root 3. dA, ds, S equals 10 equals 5 root 3. And measured, again, we get inches squared per inch, and we don't reduce that just because we can. So coordinates of moon body versus parts below, plot S versus T, sketch a smooth curve through the given points, represent the motion of the body, select the velocity, blah, 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 blah. $10, $20, $30, $50, S of T. Over here, 1, 2, 3, 4, 5. Do our best to fill in some points. 36.5 out there. 44 out there. 48.5 out there. So we try and slap a line in here. Sorry, we're going off screen there. Something like that. Don't think there's an arrow here because it doesn't go that far over. And now it says estimate at 1, 2.5, and 3.5. This is actually a very common thing we do in calculus. We use points on either side. So the best we got is the ones right next to it. So S prime of 1, we're going to use 1.5 and 0.5. 44 minus 26, 1.5 minus 0.5, 18 feet per second. Feet per second. I always double check my units even when I have no reason to. S prime of 2.5. Now we're going to use 2 and 3. This is going to be a 0. I also always leave my units out of here because they just get in the way. And 3.5, we're going to use these. We're going to get a negative number. Now, just so we're all on the same page, that looks absolutely horrible when you go to set it up, but if you get good at this, it goes relatively quickly. Try not to let it intimidate you. Another classic looking AP exam. Gallons of water tank starts to drain. How fast the water running at the end of 10 minutes? What's the average of the water flow during? All right, so off we go. Q prime of T. Q prime of 10. Negative 8,000. This was in number of gallons. This is in minutes. Fast water run around 10 minutes. Gallons of water tank, T minutes. So when derivative, put minutes on the bottom. A lot of people find that confusing early, but you might want to lock it down because it's just going to get a lot harder as things go get along. So the average rate, which I really shouldn't write derivative, Q of 10 minus Q of 0 over 10 equals negative 10,000 gallons per minute. So not that different, but different. Particle P moves on a number line shown below. Once particle moving left, moving right, standing still. Takes a little bit of practice. Get good at this. Okay, so graph the particle's velocity. I'm going to graph in red right on top. So it's open dots, but here the speed is just goes up 2 in 1 second. 2 feet per second. And it's a different, here is now velocity, not S. For the red, it's V of t, and still time on this, time in seconds. Now it's not going anywhere. So it's 0. Now it's going down at 2 and 2, -4. Now it's going 0 again. And now it's -2, if I'm not mistaken. So we do this every now and then where we put these graphs on top of other graphs. Kind of goofy. All right. So moving left. From 2 to 3 and from 5 to 6. Moving right. Zero to 1. And standing still. Lots of standing still. 1 to 2 and 3 to 5. Rock thrown vertically upwards, surface moon, certain velocity, blah, blah, blah. V of t equals 24 minus 1.6 t. A of t equals -1.6. We got units here, but I'm not going to put them in. I am going to put them in. Meters per second squared. How long will it take the rock to reach its height peak? Well, that's when the velocity is 0. -1.6 t plus 24 equals 0. T equals 24 divided by 1.6, which is 15 seconds. How high did the rock go? Well, how far was it after 15 seconds? S of 15 equals 24 times 15 minus 0.8 times 15 squared. 180 meters. When did the rock reach half its maximum height? Well, that's when S of t equals 90 meters. So 90 equals 24t minus 0.8 t squared. All sorts of ugliness, and we get a quadratic equation. T equals 4.393 seconds. Or T equals 25.607 seconds, depending or not whether it's going up or on the way back down. How long was the rock aloft? We need when S of t equals 0. So it's 24 t minus 0.8 t squared, which is 0 equals, and I know I'm running out of room, but I want to keep this in. I guess I don't have to. 24 minus 0.8 t. So that's either t equals 0 or, we don't care about that, t equals 24 divided by 0.8 should be 30 seconds. And that's all they wanted was the time. So I'm going to do that sort of thing. Notice that you could have also said, well, it took 15 seconds to get to the top. So up and down is 2 times 15. If you were smart, which clearly I am not. Velocity, body moving along the coordinate line. So we want acceleration. So I will put speed in red. And I will put acceleration in blue. All right, so acceleration will be easier for me. 3 over 1 is just 3. And then here it's going negative from about here to here. Here it's going 0. So about here. And then here it's going 3 again. And then it's negative 2. So I gotta go make up a 2. And yes, I didn't want to write on my 8 and 10. I felt bad about that. So now how about speed? Now speed's a little bit trickier. Speed is the same if it's positive. And then when it becomes negative, it bounces up. Stays there. I'm trying to draw it above so you can see it a little more clearly. And then just, oops. Forgot about this spot here. And then back up. That's speed in red. Okay, when does the body reverse direction? When if t goes positive, negative, or negative, positive. One approximate is body moving at a constant speed. 3 to 6. So from t equals 3 to t equals 6. When your acceleration is 0. Graph the body speed in red above. Acceleration in blue above. Equation for free falling surface of Mars, Jupiter. Jupiter doesn't work because Jupiter is a gaseous planet, so you just keep falling forever. But hey, I don't want to ruin the fun. So let's go with V of t equals S prime of t. So on Mars, got it? 2 times that, which is 8, 6, t. Oops, I kept that. T 16.6, t equals 4.462 seconds. Jupiter, 2 times 11.44. T equals 16.6. T equals 0.726 seconds. Bullet fired straight up, which is a beautiful image of people running for their lives as the bullet comes plunging to earth. We reach a height of blah, blah, blah. On Earth, the next Earth's height would be blah, blah, blah. How long take the bullet to get put down in each case? Let's do the moon. V of t equals S prime of t equals 0. 832 minus 5.2 t equals 0. T equals 160 seconds to top. T total is 2 times 160, 320 seconds. On the Earth, we would say 832 minus 32 t equals 0. T equals 26 seconds. Again, that's just to the top. So T total equals 2 times 26, 52 seconds. I believe I rounded. That's okay. We'll leave it at that. All right. You devise a graph for some of this problem to support the answer obtained analytically. So I would do this with the parametric like we've done before. And then if it's moving along a line, I would actually do x equals s of t down here. And y equals t. And it'd be easier to see what's going on. And I would create a window 0 less than t less than 320 and 0 less than x 350 and no, I got them backwards. 70,000. 0 less than y less than 350. And off we go. Just doing derivatives here. Minus a particle at rest. And that occurs by quadratic equation. T equals 1.451 seconds and 3.215 seconds. Describe the motion of the particle. Particle is moving left from I got to figure this out. I don't even know what I wrote in my answer key. Particles moving left. You know what? I'm going to figure this one out. Let's go with 1 second. Velocity would be negative, right? From t equals 0 to t equals 1.451 seconds. And right from, t equals 1.451 seconds to t equals 3.215 seconds. It then moves left. More than enough. Well, more than enough. Position of the body, acceleration with velocity of 0. V of t equals 3t squared minus 12t plus 9. V of t equals 0. T equals, factor out the 3. T minus 4 plus 3 is t minus 3 minus 1, so it's t equals 1 comma 3. A of t equals 6t minus 12. A of 1 equals negative 6 meters per second squared. A of 3 equals 6 meters per second squared. I'm going fairly quickly because there is so much here. I don't want to spend years on this, but it takes 12 hours to drain a storage tank, depth of fluid, find the rate while it's changing. Yeah, I got to distribute this first. Y equals 6 times 1 minus t over 12 times 1 minus t over 12 equals, and I'm just going to cut to the chase on this. Yeah, I'll do it all. 6 times 1 minus t over 6 plus t over 144 equals 6 minus t plus t over 24 squared. 24. dy dt will equal t over 12 minus 1. That's hard. When is fluid level in the tank falling fastest, slowest, right? Well, we graph it. And 12 hours. So go out here to 12. Takes 12 hours drain, sure does. That's when its velocity is slowest. So clearly it's fastest because that's the velocity. All right, there we go. That's a lot. All right, so if we graph this together, like we just found out, this is dy dt. Feeling I might have been sneaking off. And y graphs something like this. So drains faster early and slower later. And it looks like, even though this gets closer and closer to zero, it just kind of trickles away to nothing. Let me look at the original. Yeah, no. So value of y decreases quickly at the beginning and more slowly later. All right, a little bit of business stuff I threw at you earlier. Suppose that the dollar cost producing how much for me, whatever. Average cost. C of 100 minus C of 0 over 100 minus 0 equals $90. Marginal cost equals C prime of 100, which is 100 plus negative 0.2 times 100, which is $80. So this is kind of goofy, but how much does the 100 first machine cost? So C of 101 minus C of 100 equals 79.9, which is really close to our $80. Another one, monthly profit of a software company is given by blah, 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 blah. The graph, this is a logistic curve, as in you top out at some point. You can't keep selling because the market's only going to get so saturated. So up here is 10. Out here is about 200. All right. There we go. Should we limit the X value for any reason? What I just said, you can only sell so much. If you keep selling them, at some point you're just kind of wasting time. You're not making a ton more profit. You're spending money to get these. I mean, your profit is minimal at that point. So I would say no, but after a while, very limited marginal profit. And this, of course, goes on. Use Ender to graph P prime of X. The value of X is P relatively sensitive changes in X. You graph it, you're going to get something like that. And it's relatively sensitive change from about 50 to about 150. Number of software packages. After that, it's not so sensitive. At the very beginning, it's not so sensitive. So what is the profit when the marginal profit is greatest? The marginal profit is right here at about 100. So you find the max using your calculator, and the max is at X equals 106.438. We use X equals 106 for simplicity. The profit, 106. And a lot of businesses with hot products do this. They don't flood the market with iPhones because they're all valuable. So if they flood the market, then they become less valuable. You know, people are selling them secondhand cheap just to get rid of them. They don't want to do that. So what is the marginal profit? At 50, you're making $13 per unit. At 100, you're making $165 per unit. At 150, you're making 125, huh? You're making $118 per unit, and you can see we've passed the maximum point. At 150, it'll be lower. You're back down to $31 per unit. At 175, down to $6 per unit. And at 300, we have topped out. It's basically $0 per unit. You're just grinding the market into dust. What's the limit as X approaches infinity of P of X? That's that asymptote I talked about on the previous page. And actually, when we get to logistic, you'll see it's this number on top. That's the max. And this is in, what do we say it was? Thousands of dollars. Is there a practical explanation? Yeah, I would say only so many people need this special software. It's not like you're selling, Microsoft Word. You have a limit to what you can sell. So at that point, to sell more, you might have to lower your price too much, and you don't want to do that. Wow, that was a big one. Good luck and happy mathing.